Regulation 10 is one of the shortest regulations, simply stating that where necessary to prevent danger, every joint and connection in a system must be mechanically and electrically suitable for use.
So in practice, every joint or connection must be constructed so that it has the same strength as the conductors it's joining. And as a result, the integrity of its insulation and its conductance is likely to be maintained under both normal and fault conditions.
The regulation applies to all joints, from the biggest bus bar connection to the humblest plug and socket. Regulation 11 gives legal status to protective devices. Efficient means, suitably located, shall be provided for protecting from excess of current every part of a system as may be necessary to prevent danger.
Excess current, or as it's referred to in the IET wiring regulations, overcurrent, can arise from either short circuits or overloads. In the case of short circuit, just how large a current will flow depends on the potential difference between the two conductors and the resistance of the fault loop. A typical example of an overload is when an electric motor is mechanically overloaded and draws a higher than normal load current. The selection and location within the electrical system of appropriate overcurrent devices is an important part of the design process, and a number of factors have to be taken into account. For example, it is important to choose a protective device which will operate successfully given the prospective fault current and will be electrically strong enough to withstand the fault current which it will have to break.
BS88 fuses, even the smallest, are able to break 80,000 amps, a far higher figure than you'll meet in practice. However, circuit breakers vary in their current breaking capabilities and may be as low as 6,000 amps. Clearly, if the prospective fault current exceeds the current breaking capacity of a protective device, they would not be safe to use.
Discrimination has to be applied so that smaller devices operate before larger ones. This coordination of devices will allow fault-free circuits to continue to function, whilst only disconnecting those at risk. When, as with electric motors, short circuit protection is used with overload protection, these must be selected to ensure that an overload does not provoke the short circuit protection to trip, and vice versa.
The detailed design of protection systems is beyond the scope of this video, but we hope that the point is clear that faults and overloads may occur on even the best maintained systems, and well-designed and installed protection is essential for safety. For those of you wishing to know more on this topic, we do cover it in detail in other videos, especially the Understanding Circuit Protection series, available on learninglounge.com.